In this lesson, I'll show you a very simple method on how to find the lowest common multiple using prime numbers. Now remember, a prime number is a number that is divisible by itself and the number 1. And the first 8 prime numbers are 2, 3, 5, 7, 11, 13, 17, and 19. It always helps to memorize the first 8 prime numbers. So here in example 1, we're being asked to find the lowest common multiple for the following numbers: 14, 6, 33, and 20. So to start this method, we begin by writing these numbers out next to each other. So we have 14, 6, 33, and 20. The next thing we do is we ask ourselves, what is the lowest prime number that divides any of these numbers within that row? And we're looking for the lowest prime number. And that must be 2, because we have even numbers in the set. So 2 divides 14 7 times. It divides 6 3 times. It does not divide 33, so repeat that. And it divides 20 10 times. So now that we have a new row of numbers, again we ask the same question. What is the lowest prime number that divides any of these 4? And again, 2 works because 10 is even. So 2 does not divide 7, not 3, not 33, and divides 10 5 times. Let's continue this process. What is the lowest prime number that divides any of these 4? And this time it's 3. 3 does not divide 7, so rewrite it. 3 divides 3 once, and once you reach a column of 1s, you can ignore that column moving forward. 3 divides 33 11 times, and 5 is not divisible by 3, so repeat it. What is the lowest prime number that divides any of the remaining 3 numbers? It should be 5. So I'll just extend this line down. 7 gets repeated, 11 gets repeated, and 5 becomes a 1. We can ignore this column. Notice that 7 and 11, the numbers that remain, are prime numbers. So the lowest prime number that divides 7 must be 7, and that finishes off this column. We rewrite 11, and the lowest prime number that divides 11 must be 11. So the numbers that you find along here, when you multiply them, you will end up with your lowest common multiple. So 2 times 2 times 3 times 5 times 7 times 11 ends up giving us 4,620. And that is the first instance where the multiples of these 4 numbers we start with are common. And interestingly, every multiple of 4,620 will also be a common multiple of these 4. So if we were to double this, we would find another common multiple, and so on and so forth. In question number 2, we're asked, find the lowest common denominator for the following fractions. We'll apply the same technique, but we're only interested now in the denominators. So we'll write down 5, 9, and 6. And just as a reminder, the first 8 prime numbers are 2, 3, 5, 7, 11, 13, 17, and finally 19. So what is the lowest prime number that divides any of these? It must be 2. We have an even number in the set. We rewrite 5 because it is not divisible by 2, nor is 9. 6 is divisible by 2. It becomes 3. The lowest prime number that divides any of these is 3. 5 doesn't work. 9 divided by 3 is 3. 3 divided by 3 is 1. The lowest prime number that divides any of the remaining numbers is 3. That becomes a 1, and we're left only with 5. 5 is a prime itself, so the last number must be a 5. That becomes a 1, and so we multiply 2 times 3 times 3 times 5 to get our LCD. And it happens to be 90. So the first instance where 5, 9, and 6 will meet, the first multiple that is common must be 90. And then comes 180, 270, 360, and so on. I hope you can apply this technique for your problems. If you have any questions, leave it in the comment section below and I'll gladly help. Thanks for watching.